Hello everyone, welcome to MemoNeet. I hope all of you are doing good. So welcome to yet another amazing session with me. I am Aprachita, your chemistry SME. So I hope all of you have prepared well and given the BPT4 exam. So tell me how it was. Like you can tell me in the comment section ki how your BPT4 exam went and how much marks did you score in that, right? So I hope you know that we have provided the video solutions for the BPT4 exam on YouTube. Okay, so you can go and watch those solutions, video solutions by our chemistry SMEs only. So in case you were not able to understand any question or you were facing any difficulty, so go and watch that video solution. So there all your doubts would be clarified. Okay, so now what next? So the next thing is our BPT 5, right? So we are now going to prepare for the Bhramastra part test 5. So what chapters are going to come in that Bhramastra part test 5 that I am going to show you. So students, as you can see in this that the Bhramastra part test 5, okay, it's going to be on 30th of June, means next Sunday, okay. So you have full 1 week for prepare for that. So the chapters that are going to come are current electricity in physics, electrochemistry in chemistry, and human reproduction in biology. Okay, so these are again your basic chapters, but they carry good weightage. And since we promised you that we are going to cover the 11th and 12th syllabus simultaneously, so in the last part test we covered the class 11 syllabus, right? So this one we are going to cover class 12th chapter. So all these chapters are from class 12th in all the 3 subjects. So electrochemistry is again a very important chapter from class 12th. All right, so that's what we are going to study today. Okay, so as you can see, the topic for today is electrochemistry. So now the thing is that what is electrochemistry? What do we understand or what are we going to study in electrochemistry? So the very first thing is let's learn about the basic things. So students, electrochemistry is actually the study of production of electricity from energy released during spontaneous chemical reactions and use of that electrical energy to bring about the non-spontaneous chemical transformation. So basically what is it trying to say? That electrochemistry actually deals with the relation between your electrical energy, okay, and chemical energy. Means how the electrical energy is used to carry out the non-spontaneous chemical transformations and how the spontaneous chemical reactions, the energy released from those spontaneous chemical reactions are converted into electrical energy. So that's what we are going to study in chemistry, electrochemistry. So it is basically related to the relationship between the electrical energy and the chemical energy. So we will be talking about reactions, of course, it's chemistry, but then we will be talking about the relation of that chemical energy with the electrical energy. Okay, so in electrochemistry there are 2 types of cells that we are going to study. Okay, the first one is electrochemical cell. We call it as galvanic cell also or voltaic cell also. Now what is this cell does? This is the cell that actually converts the chemical energy into electrical energy. Okay, means how the energy that is released during the spontaneous chemical reactions that is used to produce electricity. So whatever process happens, so we call it as the electrochemical cell, okay, or galvanic cell is another name. Now what is electrolytic cell? So you might have heard of the word electrolysis, no? So electrolytic cell is the one where electrical energy is used to carry out the chemical reactions. Means where your electrical is transformed or changed to chemical energy. So we will call that as electrolytic cell. Okay. कि how we are using the electricity, the current to carry out the non-spontaneous chemical transformation. Non-spontaneous means that do not occur on their own, right? Spontaneous means that can occur on their own. So non-spontaneous chemical transformations, how they are carried out using electrical energy, that's all we are going to study in the electrolytic cell. Okay. So the very first one is the electrochemical cell. In today's session, I'm going to focus on the electrochemical or the galvanic cell. Okay. Now here you can see the electrochemical or the galvanic cell, students. So I have already told you that galvanic cell is actually an electrochemical cell, okay, that converts the chemical energy of a spontaneous redox reaction into electrical energy. Now what do you mean by redox reaction? So there is this complete chapter that we will be studying of redox reactions, but you might have studied about it in your lower classes. Redox reaction is a reaction where reduction and oxidation takes place simultaneously. Okay, now there are many definitions for reduction and oxidation. I'll recall for you. So reduction means either there is an addition of hydrogen or removal of oxygen. Okay, or whenever there, in terms of electrons, so whenever there is a gain of electrons, we call it as reduction. Okay, students, so these are the three things which we call as reductions. Now if I talk about oxidation, so oxidation is opposite of reduction, means if there is addition of oxygen or removal of hydrogen from any substance, so we call it as oxidation, or if there is loss of electrons. Okay, so if there is loss of electrons, we will be calling it as oxidations. So you know that in every reaction there is either gain or loss of electrons. So every reaction is somehow a redox reaction. So what happens in this electrochemical cell is that whatever chemical energy we are getting from this spontaneous redox reaction happening inside the cell, that is being converted to the electrical energy. Okay, so the Gibbs energy, we'll study what's Gibbs energy. Gibbs energy of the spontaneous redox reaction, it is converted to electrical work. So that electrical work can be used for running a motor or other electrical gadgets like heater, fan, geyser, and etc. and all of that. Okay, so now we will be seeing what is all present in this electrochemical cell. Okay, so here students, basically you can see there are two half cells. Okay, we call them as half cells. There are two beakers which we call them as half cells, in which two metallic electrodes, they are dipped into the electrolyte solution. Okay, so they are dipped into electrolyte solution. You know, electrolyte is the one which actually dissociates or ionizes into ion or passage of the current, and it conducts electricity. Okay, so these metallic electrodes are dipped into their respective electrolytes, and these electrodes are connected through wires to the voltmeter and switch, okay, externally, and internally they are connected with each other using a salt bridge. Okay, now whatever this salt bridge is and what is the function, everything we will discuss later on. I'm just telling you the construction of this cell. Okay, you know, sometimes both of these electrodes can be in one electrolyte only. In that case, we will not require a salt bridge. Now here what we have taken is, we have taken a zinc electrode and a copper electrode. Okay, this is the cell that we have taken here. So in this case, the reaction that is happening is zinc plus Cu2 positive gives zinc 2 positive plus copper. Now here two half cell reactions are happening. Copper 2 plus ions. See, what happens is, students, that ions from the solution can move to the electrode and can deposit it there, whereas the metal from the electrode, it gets dissolved into the solution also. So what is happening in this case is that copper ions are gaining electron and they are converting to the copper metal. Now just now I told you what is gain of electrons, called reduction. So this is our reduction half cell reaction. Okay, Whereas zinc ions, zinc metal, it is losing 2 electrons and converting into zinc ion and coming into the solution. So we call it as oxidation, because loss of electron is happening, so that will be known as oxidation. Okay. So these two half cell reactions are happening. Let's learn more about it. So these reactions, they are occurring in two different portions of the Daniell cell. Daniell cell is again another name of it. Okay. So the reduction is happening on the copper electrode, just now I told you, and oxidation is happening on the zinc electrode. So these two portions are called half cells or redox couples. Okay, redox couples भी बोल सकते हैं, we can call them as half cells. Okay, तो जहां पर reduction हो रही है, right, in the copper half cell reduction is happening, so we will be call it as the reduction half cell, and zinc electrode को हम बोलेंगे the oxidation half cell, because there is oxidation means loss of electrons happening in that case. Okay, in the case of zinc, loss of electrons, copper के case में gain of electrons is happening. Now, what I told you that at each electrode, electrolyte interface means whenever this electrode is dipped into an electrolyte, what happens? There is a tendency of metal ions from the solution to deposit on the metal electrode, trying to make it positively charged. Means the metal ions, they can move from the solution and get deposited on the electrode. Moreover, what happens in the next case, the metal atoms of the electrode, they have a tendency to go into the solution as ions, like what is happening in the case of zinc, right? The metal atom also have a tendency to go into the solution, all right, in case of to make ions and leaving behind the electrons at the electrode and trying to make it negatively charged. Okay. Now what happens at equilibrium? There is a separation of charges. Okay, there will be separation of charges, of course. जब electrons gain or loss होंगे, there will be separation of charges, and depending upon the tendencies of the reactions, ki what are the tendencies of the two opposing reactions, your electrode, the two electrodes that you are having now, it can be positively charged also and negatively charged with respect to the solution in which they are dipped. Okay, so of course jab one electrode is positively charged and one is negatively charged, there is a charge difference, no? So in that case, a potential difference develops between the electrode and the electrolyte. Okay, क्योंकि इस जिस electrolyte में वो dipped है उसके with respect to now there will be a charge difference. So because of that charges there exists a potential difference. Okay, now this potential difference is known as electrode potential. Very very important term, electrode potential. Okay, so these are the important terms that I am explaining. So whenever there is this charge that gets accumulated on your electrodes, okay, so there exists a potential difference between the electrode and the electrolyte, which we call as electrode potential. Okay, but whenever we are taking all the species, okay, and the concentration of the species that are there in a particular half cell is unity. Okay, unity means 1. So in that case, the electrode potential is called standard electrode potential. Okay, in that case we will call it as standard electrode potential. So earlier, like standard reduction potentials हम बोलते थे, now we call them as standard electrode potential. Okay, now the important thing is that in the half cell in which oxidation takes place is called anode. Look at here. So zinc के case में oxidation हो रही है, right students? Loss of electrons is happening in the case of zinc. So this one will be known as the anode. Okay, so let me write here again for you people. Okay, so the one where your oxidation happens is known as anode. So zinc is the anode here, and the one where reduction happens is called the cathode. So copper is going to be the cathode in this case. Okay, right? So oxidation happens at anode and it has negative potential with respect to the solution, of course. Okay, and the other half cell where reduction takes place it will be called as cathode and it will have a positive potential. So keep that in mind, that anode have a negative potential, okay, with respect to the solution, and cathode, where reduction takes place, they have a positive potential with respect to the solution. Up there is negative positive potential in anode and cathode, so there will be a potential difference, right, between the two electrodes. As soon as the switch is in open position, kya hoga? Electrons will start to flow. So try to understand this, students. Whenever just now we saw na ki anode will be at negative potential and cathode will develop positive potential with respect to the solution. So now there is a potential difference between the two electrodes. Okay, charges ka difference hai. So we have connected this cell to a switch, right? So when the switch is in on position, when we will turn on the switch, what will happen? The electron will start to flow from the negative electrode to the positive electrode. So this arrow indicates the flow of electron from zinc to copper, because zinc is the negative electrode here and copper is the positive one. Okay, so this is the flow of electron, but the flow of current is always opposite to the flow of electrons, right? This you know by convention. So the current will flow from copper to zinc. So electrons always flow from negative electrode to the positive electrode, and the direction of flow of current will be opposite to that. Okay, so now students, this potential difference that exists between the two electrodes of a galvanic cell is called cell potential, and we measure it in volts. Okay, this is very important term. Again, the cell potential. Okay, so what is cell potential? It is actually the difference between the electrode potential. So electrode potentials are nothing but the reduction potentials of the cathode and anode. Okay, we can call it as the cell electromotive force, means EMF of the cell when no current is passed through the cell. Okay, so now this is by convention, students, in electrochemical cell, ki whenever we have to represent the cell na, so there is kind of representation also that we will discuss. So in that representation, anode is kept on the left, okay, and cathode is kept on the right while we are representing the galvanic cell. Okay, so like what is this vertical line and all of that I will tell you. Okay, so the EMF of the cell is positive and is given by the potential of half cell of right hand side minus the potential of half cell of left hand side, क्योंकि जो left hand side है वो anode है, उसका negative potential है, right? So this is important. E cell is E right, or you can say E cathode minus E anode. So why we are saying कि EMF of the cell is positive? क्योंकि E cathode is always having a positive potential, so positive minus, and यहाँ पर anode is having a negative potential, so minus minus will be plus. So ultimately your answer is going to be positive, right? So this is how EMF of the cell is calculated. This is important. Now let's say I am having a cell reaction where copper plus 2 silver ions 2Ag plus gives copper 2 plus and 2Ag. So the reaction that takes place at cathode is 2Ag plus 2 electrons give 2Ag. आप देख सकते हो, you can see this is reduction happening and copper is getting oxidized to give copper ions. So 2 electrons का loss हो रहा है, that is happening at anode. Now I told you how to write this. So a galvanic cell is represented by putting a vertical line between metal and electrolyte solution. So first of all, we will be writing the anode on the left hand side. So we will write copper, which was in solid state, right? क्योंकि वो electrode में है. And we will put a vertical line like this. Then we will write the electrolyte. Copper 2 plus ions are there in the electrolyte. It's in aqueous state, right? Electrolyte form में है. Then we will represent the salt bridge by these double vertical line. Now we will write the reaction of the cathode. Okay, so here Ag plus is getting converted to silver and get it deposited on the cathode. So S means solid, Aq means aqueous. So this is how the cell is going to be represented, and E cell will be E right minus E left. So right पे we have E Ag plus 2 Ag minus E copper 2 plus 2 copper. Means you can say E cathode minus E anode. Okay, so this is how we can calculate the EMF of the cell. Now my question is that how to calculate these E cathode and E anode values. How we will get these values in the case of a galvanic cell or an electrochemical cell. So that's what we will be discussing in the measurement of electrode potential. So the thing is, students, that the potential of individual half cell cannot be measured. Okay, we cannot measure the potential of individual half cell. We can just measure the difference between the two half cell potentials, and that difference gives us the EMF of the cell, right? So then the thing is that how can we measure the half cell potentials? So students, to calculate that, if we arbitrarily choose the potential of one electrode, means one half cell, then for the other half cell we can determine according to that. Okay, so according to convention, we have taken a half cell which is called standard hydrogen electrode. Okay, so standard hydrogen electrode is taken to calculate the standard electrode potential of various cells, and it can be represented like this. Okay, platinum, H2 and H plus. So this standard hydrogen electrode, it is actually having a zero potential. So the value of E naught would be 0 at all temperatures corresponding to the reaction. So what is the reaction happening? The H plus ions are gaining an electron and they are converting into hydrogen gas. Now what is this SHE? Let me show you. See, actually we have written a platinum. So it is actually a platinum electrode which is coated with platinum black. Okay, so this electrode is dipped in acidic solution and pure hydrogen gas is bubbled through it at 1 bar pressure. Okay, so here the concentration of both the reduced form and the oxidized form of hydrogen is maintained at unity. Okay, so the concentration would be unity in this case because we are calculating the standard electrode potential. Okay, so in that means that the pressure of the hydrogen gas is in this case is 1 bar and the concentration is 1 molar. Okay, so using this standard hydrogen electrode, we can actually calculate the electrode potentials for the various half cells, and then we can use those values, and they have been determined already. Now what happens, let's say at 298 Kelvin, the EMF of the cell, so we will be taking the cell, so one half will be your standard hydrogen electrode and that will be taken as the anode. All right, the SHE, standard hydrogen electrode, that will be taken as anode, and your whatever half cell you are having, that you can the cathode. So that will give you the reduction potential of the other half cell, means the one that you have taken as the cathode. Reduction potential or electrode potential means the same thing. Okay, reduction potential or your electrode potential. Okay, now again, if the concentrations of oxidized and reduced forms of the species are unity, so cell potential is the standard electrode potential, E naught. Okay, so whenever we use this naught now, it means we are talking about the standard values whenever the concentration is unity. If this naught is not there, then it's not the standard electrode potential, it's similar like simply the electrode potential. Okay, now E naught cell will be given as E naught R, like just now we have discussed it. E naught R minus E naught L means cathode minus anode. Now for hydrogen it is taken as 0. So the E naught will be equal to E naught R only. Alright. Now let's say we have taken an example for copper. So we are calculating the electrode potential for copper 2 plus 2 copper. Right, concentration is unity. So the measured EMF, whatever the measured EMF is, that is 0.34 volts. Okay, and it is also the value for standard electrode potential. Why? Because its E naught will be equal to E naught R only, so standard electrode potential भी उतना ही होगा, because if we subtract 0 from it, right? So similarly we can talk about here for your zinc. So for zinc, it is calculated as minus 0.76 volt. Okay. So for zinc, it's minus 0.76 volts, and for copper, it is 0.34 volts, which we have calculated using the standard hydrogen electrode. Now these values we can use in our formula, this one, E cathode minus E anode. So these values we can use here, and we can calculate the E cell. Okay. So students, what do these positive and negative values indicate? So the positive value of the standard electrode potential in the first case indicates that the copper 2 plus ions get reduced more easily than H plus ions. Means if electrons are present, copper 2 plus ions will readily gain electrons to convert to copper than the hydrogen ions. That is what this positive reduction potential or electrode potential means. Okay, means it is having more reduction potential than hydrogen. Hydrogen creates 0 na, so here it's 0.34, means more reduction potential means more tendency to get reduced. Okay, so all the ions that have positive reduction potential will have more tendency to get reduced than H plus ions. Okay, and the reverse process cannot occur, that is hydrogen ions cannot oxidize copper ions. Okay, now uh, so here, that's why here we can say copper does not dissolve in HCl. All right, that's the reason you might have studied it earlier also. Now the negative value of standard electrode potential, what does that indicate? It indicates that hydrogen ions can oxidize zinc, or zinc can reduce hydrogen ions, because in this case if I talk about zinc ions and hydrogen ions, so hydrogen ions have more tendency to gain electrons, means to get reduced, means it can reduce the zinc. Okay, zinc metal or zinc can like reduce the hydrogen ions. Hydrogen can oxidize zinc in this case. Now, so the reaction we can write it like this. Okay, the one that we were discussing in our galvanic cell. Okay, and the sum of two reactions is here, zinc plus copper 2 plus gives zinc 2 plus and copper. So the EMF is E naught cell minus E naught of cathode minus E naught of anode. This we have calculated using the standard hydrogen electrode, and the value comes out to be 1.10 volt. So this is the standard electrode potential for the cell, for the given cell. Okay, E naught means standard. Now I will show you the standard electrode potentials of various ions, okay, at 298 Kelvin. This table I have taken from the NCERT. You can find it there, okay, don't need to worry. So see, this is why NCERT is very important. Everything is given in NCERT. Okay, so now you can see this is the oxidized form and this is the reduced form. So here fluorine atoms, they are gaining electrons and converting to fluoride ion, and you see their reduction potential is 2.87. Okay, this is your hydrogen in this case, and below hydrogen you can see negative. Now what does that mean? So it means that the standard reduction potential or electrode potential for fluorine is highest, means fluorine has the maximum tendency to gain electrons. I am talking in terms of gain and lose electrons so that it becomes easy for you to understand. Otherwise they have given कि fluorine gas has a maximum tendency to get reduced. That's the same thing, na? Gain electrons or to get reduced to give fluoride ions. So now you might have studied, students, ki if something is getting reduced, it can act as an oxidizing agent, right? It can oxidize another atom. So that's why we can say ki fluorine gas will be the strongest oxidizing agent. And when we are moving downwards in this series, the strength of oxidizing agents for the left hand side, it is decreasing, okay, from fluorine up to lithium. Now just look at the lowest value. Lithium gains electron, lithium ion gains electron to convert to lithium. Now its value is minus 3.05, minus 3.05. Just see how much difference it is having from hydrogen. Now what does that means? That lithium has the least this electrode potential, means it has least tendency to gain electron, okay, least tendency to get reduced. So that is why it will be the weakest oxidizing agent. All right, so if it cannot get reduced, so obviously it will be the weakest oxidizing agent, no? Okay, but it will be the most powerful reducing agent. So of course, if the strength of oxidizing agent is decreasing, the strength of reducing agent is increasing. All right. Of course, so it can act as a reducing agent. Means lithium can readily lose electron. Itself it will get oxidized. Okay. But and it can act as a reducing agent. So this table is very important. You must know how to study this, because in your NEET exam, I have found many questions that have been asked from this series. Okay. Electrochemical series, where they will give you some values and they will tell you which one will be the most strongest oxidizing agent or strongest reducing agent, which one will get reduced first. Okay, so I have explained you in very simple terms. Still, if you are not able to get it, you need to tell me. Okay, if you are not telling me, so I cannot help you then, right? So please let me know if you are able to understand this concept or not, because this is very important class. Okay, you will see that how many questions have been asked from this particular series. So just try to keep that in mind कि if the electrode potential is more, so the species will have more tendency to get reduced and they will be acting as the oxidizing agent. And if the electrode potential is more negative, so the species have least tendency to get reduced and they will be acting as the reducing agents. Okay. Alright, so this was related to your electrode potential, standard electrode potential, जहाँ पर concentration was taken to be unity. Concentration of all the species was taken to be unity, right? But now students, if it's not always कि the concentration will be unity, right? It's not always true. Now we have the another important topic, Nernst equation, which is very important. Again, you will find a lot of numericals based on that. Okay. So this is your concept lecture. When we will be discussing the revision for the next BPT, then I will be telling you about the numerical portion as well. Okay. So students, now here I have taken another electrode reaction. Like for any metal ion, it is in aqueous state. It will gain electrons and converting to your metal. Okay. Now, according to Nernst, the electrode potential, okay, now we are not talking about standard electrode potential, we are talking about E. If I am simply writing E, that is the electrode potential, because here the concentration are not unity. So here it will be equal to the standard electrode potential of the cell minus RT upon NF natural log M, means product, divided by the reactant, means Mn plus. बट क्लास इफ आई हैव एनी सॉलिड ना, सो कीप दैट इन माइंड कि ये जो सॉलिड होगा यहाँ पर हम कंसंट्रेशन हमेशा यूनिटी रहेगी. ओके, व्हेनेवर यू आर हैविंग एनी सॉलिड प्रोडक्ट, सो इन दैट केस द कंसंट्रेशन इज ऑलवेज टेकन टू बी unity. Okay, so if I take it to be unity, this is the equation I am getting. E naught cell minus RT upon NF log 1 upon Mn positive. Now E naught cell तो हम ऑलरेडी डिफाइन कर चुके हैं. स्टैंडर्ड इलेक्ट्रोड पोटेंशियल फॉर दिस पर्टिकुलर सेल, लेट्स से इफ इट इज कॉपर, राइट, ई नॉट, if I am talking about copper, तो यहाँ पर आप लिख सकते हो कि the value of E naught would be 0.34. So that is experimentally determined. Okay, but we need to find the E cell. Okay, R is the gas constant. In this case, we are taking 8.314 joule per Kelvin per mole. F is the Faraday's constant, 96487 coulomb per mole. Like sometimes हम इसको 96500 coulomb per mole भी ले लेते हैं. Okay, but this is the exact value. T will be the temperature in Kelvin and M will be the concentration of the species. So what I am getting is E cell will be equal to E naught cell minus RT upon NF log 1 upon Mn positive. Now N क्या है यहाँ पर class? N is the number of electrons that are gained or lost, right? I hope this is self-explanatory, that's why I didn't tell you. So here it's Ne, na? Ne matlab how many electrons are being gained or lost. So that's your N. Now for Daniell cell, which we have been discussing, like for copper and zinc ions. So for copper ions, see what you can write for cathode. E naught for copper minus RT upon 2F, because copper के case में how many electrons were involved? 2 electrons were involved, right? तो अगर 2 electrons involved है, so we can write this thing. Okay, concentration of copper ions. And for anode also same equation can be written, because for zinc also 2 electrons were involved. Okay, now what is the cell potential? We have just discussed. Now we are not talking about the standard, keep that in mind, but formula remains same. So the E cell, see earlier E naught cell was what? E naught right minus E naught left, na? E naught cathode minus anode. So if I am talking about just the electrode potential, so that will also be same, E right minus E left. So that's what I have written here. Okay, E naught for copper minus RT upon 2F and this value. So these two values we have put in this equation. See, the ultimate result is important. For your Neet, you need to remember the result. But why I am telling you the derivation or the concept? Because when we learn the derivation or the concept, we just don't have to cram it. सिर्फ रट्टा लगाने की जरूरत नहीं है, हम समझ के करेंगे, right? We will do it by understanding the things. So ultimately जो last equation आएगी, that you have to remember. Okay? So हम ये E naught values को एक साथ लिख लेते हैं. Okay? E naught for copper, E naught for zinc minus these values. Okay? RT upon 2F को भी हमने common ले लिया यहाँ पर, like this. So we have taken RT upon 2F as common. Now class, can you tell me what is this will be? Socho, try to understand what is this. E naught copper minus E naught zinc. So that is E naught cell na, the standard electrode potential of the cell, right? So इसकी जगह हम लिखेंगे E naught cell minus RT upon 2F. अब देखो log A minus log B. I hope this you know. Of course if you have not studied maths, so no issues. ये फॉर्मूला याद रखना. आप सोचोगे कि मैम इसके साथ ये कैसे आ गया. So log A upon minus log B होगा, तो it will be log A upon B. तो यहाँ पर ये था ना log of 1 upon copper ions minus log of 1 upon zinc ions. So when I will solve it na, what will it come? I will show you. So log of 1 upon copper ions upon 1 upon zinc ions. ठीक है, तो now obviously it is in denominator, तो reciprocal हो जाएगा. So you will be getting log zinc upon copper plus. So this is how this expression has come. So don't get confused in any step. If you are facing any issue, you can ask me in the comment section, okay, or in the telegram as well. So here you have got the value of E cell. और अब हम क्या देख सकते हैं, that the value of E cell depends on the concentration of copper ions also and zinc ions also. Okay, so it will increase with the concentration of copper ions and it will decrease with the concentration of zinc ions. Now you know this is natural log. If you have to convert it to log to the base 10, so हम इसको multiply करते हैं with 2.303, then it is log to the base 10 natural log A अगर कोई है, let's say. So this you also should know. क्योंकि ये जो 0.059 आया है, ये हम इसको multiply करेंगे 2.303 RT upon 2F, then it will become log this one. Okay, ln is natural log, log is log to the base 10. Okay, and these are the values that we have put. R and F की value just now I have told you, T is 298. So when you put these values, the result will be 0.059 upon 2. N की value हमने put नहीं करी है. Okay, because N is not, हमें एक general equation चाहिए ना, and N will be different. So that's why I have taken N as it is. Okay, so in the same way you can write it like for this reaction here, nickel is changing to nickel 2 plus and silver ions are changing to silver. Okay, so the reaction would be E naught cell minus RT upon 2F. Again 2 electrons are involved in this case, log of Ni2 plus upon Ag plus square. Of course हम इसको balance करेंगे ना, right here it is balanced now. तो please note कि ऊपर जो term है that will be the product upon the reactant. Okay, now so अब हम इसको generalize कर सकते हैं students. We can generalize it that for a reaction AA plus BB and N electrons are involved and we are getting this. तो ये जो होते हैं these are the stoichiometric coefficients. तो E cell क्या होगा, E naught cell means standard potential minus RT upon NF log of Q. Now Q means the concentration in this case, like concentration of product raised to the power small c, D, and concentration of the reactant. ऑफ कोर्स जो सॉलिड स्टेट में रहेगा उसकी कंसंट्रेशन 1 होगी, इसलिए हमने यहाँ नहीं लिखा. ओके, वी हैव नॉट रिटन दैट. So this is your final Nernst equation. Keep that in mind. Okay, if you don't want to remember this, just remember it will be 0.059 upon 2. Then this will not be the natural log, it will be log to the base 10. Okay, so you can say E naught cell minus 0.059 upon n log to the base, log q, like same thing. Okay, so this is how Nernst equation is written. So students, now we will be discussing the equilibrium constant from Nernst equation. How can we calculate the equilibrium constant from Nernst equation? So if I see the reaction that we have been discussing till now, zinc plus copper 2 positive gives zinc 2 positive and copper. So in this case, as time passes, what happens? The concentration of zinc 2 plus ions is going to increase, right, with time, and the concentration of copper 2 plus ions is going to decrease, and the voltmeter reading also will be decreasing with time. Now a moment will come when there will be no change in the concentration of zinc 2 plus ion and copper 2 plus ions, and the voltmeter reading would also be 0. So at that time we will say that equilibrium has been attained, right? Means at that time the concentration is not going to change and the voltmeter reading would also be 0. So in that case we will say ki equilibrium has been achieved. Okay, so students, at that time E cell would be 0. So at equilibrium you should know that E cell is going to be 0. Now let's apply the Nernst equation. So E cell is E naught cell minus 2.303 RT. Okay, I am writing in log to the base 10 upon NF. Na? So for this N is equal to 2. So I am writing here 2. Then the log of concentration of zinc 2 plus ions divided by the concentration of copper 2 plus ions. Now E cell is 0. So I will put 0 here. Okay. So E naught cell and the same thing minus 2.303 RT upon 2F log of zinc 2 plus upon copper 2 plus. Okay, now from here the value of E naught cell will come out to be 2.303 RT upon 2F. Now students, this thing at equilibrium, this thing will be the Kc, that is your equilibrium constant. Okay, so this is the equilibrium constant, Kc. So in the place of log of zinc 2 plus and copper 2 plus, I will write log Kc. Okay, so log Kc is there for this reaction, and again at the temperature 298 Kelvin, what we can write is by putting the values of R and T. So the value of E naught cell would be 0.059 upon 2 log Kc, right? And this E naught cell has been calculated to be 1.10 volts. We have just calculated it now, remember, 1.10 volts. So from here I can calculate the value of log of Kc. So 1.10 into 2 divided by 0.059. See, I am showing you ki how can we calculate the equilibrium constant. Okay, so in that case it will come out to be 37.288. Alright, so from here Kc will be anti-log of 37.288. So it will be 2.10 in 10 to the power minus 37. Okay, sorry, not minus, 10 to the power 37. Yes, at 298 Kelvin. So from here you see we have calculated the equilibrium constant for this reaction. So in general we can say you have to keep this formula in mind, that E naught cell would be equal to 2.303 RT upon NF log Kc. Okay, so this formula we will be using for solving the numericals. How can we calculate the value of equilibrium constant? Okay class. Now we will see that how can we calculate the Gibbs free energy of the reaction. So you know that electrical work done in 1 second, okay, it is equal to the electric potential multiplied by the total charge passed. Means how much charge is passed in that 1 second. So if we want to obtain maximum work from a galvanic cell, so charge has to be passed reversibly. So the reversible work done will be equal to the decrease in Gibbs free energy. All right. So how can we calculate the Gibbs free energy? So this is the Gibbs free energy for reaction delta G. So E is the EMF of the cell, okay, electric potential what we are saying, and the NF is the charge passed. All right, so we will multiply them. All right, and it will be of course negative. So for a spontaneous reaction, so NFE cell. All right, so that's going to be the case. So students, this will be the formula for the Gibbs free energy of a cell, okay. So you will see this thing in thermodynamics also, intensive and extensive thermodynamic properties, okay. So actually the value of delta G that depends on the value of the number of electrons, okay. So here in this case delta G for this particular reaction will be minus 2F E cell, okay. But if I like compare it, like if I multiply it with 2, so it will become minus 4F E cell, okay. But again, if we are talking in terms of standard electrode potential, that is the concentration of all reacting species, if we take as unity, then E is going to be equal to E naught cell. So delta G kya ban jayega? It will be minus NF E naught cell if we are talking about the standard electrode potential, okay. So from the measurement of E naught cell, we can actually get or obtain the value of standard Gibbs energy of a reaction, which is an important thermodynamic quantity. And again, we can calculate the equilibrium constant by this equation. So these two equations you have to remember, delta G naught, okay, which is minus NF E naught cell, and delta G naught will be minus RT log K. Okay, K again is your equilibrium constant from the reaction. From here now we can put the value of E naught, and then you can just multiply it. You will see, okay, I'll show you. So it's NF E naught cell na, so minus NF, okay, and can you see E naught ki value kya hai? 2.303 RT, or if I write in terms of natural log only, RT natural log Kc upon NF, okay. So यहाँ से NF and NF will cancel and you will get minus RT log K. See, this is how we have got this equation. So please remember these equations, as these will be important in solving the numericals. Now students, I am giving you the numericals. See, I usually give you some questions at the end of the session, but I don't find the answers in the comment box. So this is an important chapter, and the numericals are also very important. So I want all of you to give the answer to this question in the comment section, okay. Then I will tell the names of the students also who have answered this in the next class, okay. I will take the names in the video also. So please answer this. It's a very simple NCERT example question that I am going to give you, so you can practice it also. All right. So here is the question, students. The standard electrode potential for the Daniel cell is 1.1 volt. Okay, E naught cell is given 1.1 volt. जो अभी हमने किया है. Calculate the standard Gibbs energy for the reaction. Delta G naught की value you have to find out. And I have just given you the formula, which is minus NF E naught cell. F की value you know what is there. N you can find out from this particular reaction. So it will just take 2 minutes to solve this question. So just use these 2 minutes after you watch this lecture and immediately comment the answer in the comment section, okay. So I'll be waiting for your comments. I need the comments from all of the people who are watching this lecture. So it's a very simple question. Try to solve it and give the answer, okay. And students, if you are liking the lectures, you are understanding everything, so you can share these lectures with all your friends. Subscribe to the MemoNeet channel and share these interesting video lectures with your friends so that they can also study it for free, right? We are giving you these lectures for free, so make full use of it and definitely share it with your friends also, okay. So I'll be meeting you in the next session for electrochemistry. So for this much is enough. And in the next lecture, we will be talking about the other important concepts, electrolysis, electrolytic conduction, and everything. So until then, take care students, keep learning, bye bye, and don't remember to post the answer in the don't forget to post the answer in the comment section. Okay, thank you so much, bye.